In this video, I'm going to show you how you can generate the large-scale version of Contoso Retail Data Warehouse from Microsoft by using Python. So what I've done is I've created a project on GitHub by using ChatGPT, which actually uses Python to create a large-scale version of the sales dataset provided by Microsoft and also add some other tables as well. So you can also use that by cloning or downloading it from the releases section. You can download the code from here, or you can also clone the project. So let's try to clone it. So we can open that inside the terminal, and all you need to do is git clone and paste it here, and it will copy that project inside your local directory. So let's wait for that to complete, and this is the structure of that particular project. So to execute or generate some data, what we need to do is first we need to make sure that the Python is actually installed on your system. Then you need to create a virtual environment, and for that I've already provided the scripts to do all those steps. So first let's go to that particular directory that we have actually cloned, and then we need to go to scripts folder and we need to create the virtual environment. So let's run the create when.ps1, and it will generate that virtual environment based on the requirements.txt file that is actually included in the project. So let's wait for that to install all the libraries. So once the creation of virtual environment is complete, what we can do is activate that virtual environment. But before that, we can also try to sync the virtual environment. So there is a script inside the scripts folder that will actually sync the virtual environment with the new changes in the requirements.txt. So in future, if I actually push some changes to the GitHub that requires some new libraries that are mentioned in the requirements.txt, you can actually do a git pull and then run that particular sync when file so that you can update the virtual environment based off the requirements.txt, and you will find that file inside the scripts folder sync virtual environment. So if I run it, it will try to create a hash file that will actually track all the changes inside that virtual environment, and later when you actually try to update the virtual environment, it will tell you whether there are changes or not. So if I run that file once again, it says that virtual environment is already up to date. And you can also see that it has actually activated the virtual environment. What we can first do is deactivate it so that we can use a script that actually also activates the virtual environment in case if you're actually coming back to this particular project tomorrow or a bit later. So what you need to do is just go to scripts folder and run the activate when file, and we actually need to do a dot source for this particular one. So you need to type dot scripts and then activate when, and that will actually activate the virtual environment. And the next thing that you need to do is just go to the scripts folder and use the the run UI file. So if I run it, it will actually open a UI in the browser that you have selected, and based off this browser itself, you can actually generate all the dataset that you need. So on the left hand side, you will find different kinds of presets for that start from 100,000 till 500 million. You can also customize that. You do not need to rely on those presets. And in case if you want to apply a preset, you can simply select one of them, click on apply, and that will change the values that are available in different section. So the first section is for the output. There are three modes that are actually supported: CSV, Parquet, and Delta Parquet. CSV mode contains the CSV file for dimension and the sales, and as well as there are SQL scripts that will allow you to import the data from the CSV files inside the SQL server. Then we have the Parquet that you can use. Then we also have the Delta Parquet in case if you want to import the data inside a Fabric Lakehouse, you can use that. Then we have this option that will actually allow you to skip over the sales order number and the sales line number column so that the file size is actually reduced by a lot. So let's select that, and we are going to use the Parquet format. Then you can specify the date range, start range, as well as the end date. And then you have the calendar option to include either the week columns, ISO week columns, or the fiscal columns. You can specify the first month of the fiscal year as well. Then in the volume, you need to specify the sales rows. The drop down basically shows how many CPU cores should be used for generating the dataset. So the task of generating the sales table can be actually split across multiple CPU cores. That will actually reduce the overall generation time. And in case if you have a CPU that doesn't have a lot of cores, you can actually reduce that to, let's say, 2 or 4. But in case if you have a more advanced CPU, then you can increase that to 10 or 16. Then we have the chunk size. Chunk size basically means the amount of rows that will be actually written in a single file. So in case if you have used the CSV format, you will see that every CSV file will have 1 million row. And in case if you've used the Parquet format, you will notice that first it generates the chunk of 1 million, then it will actually combine all the smaller Parquet files into a single Parquet file. But in case of CSV, I've actually chosen to go with a split version of CSV so that when you try to import the data inside SQL Server, you do not try to import a very large file at once. Instead of that, you run the command file by file so that it doesn't actually consume a lot of memory in a single import. So you can also customize this chunk size that will be actually applicable to the Delta Parquet as well. And then we have the dimension option. You can specify how many customers you want, how many products you want, the physical stores, and the number of promotions that are actually active in a particular year. Then we have the pricing behavior. So the price columns inside the sales table, such as the net price, unit cost, unit price, discount amount, they're actually derived from the products table itself. So first the engine builds the net price and I think unit cost columns inside the products table. Then on the basis of that, it generates the price columns inside the sales table. And in the drop down, you have this base product value scale. So the benefit of this option is that in case if you are generating, let's say 1 billion rows, then you will notice that the aggregations that you actually show in the visuals, such as sales amount or cost amount, those numbers will be really large and will be difficult to analyze. So in that case, you can actually reduce the scaling. You can actually apply the value scaling on those values so that instead of showing, let's say, 1 trillion, you actually are showing only 1 million, but the number of rows in the data set is still 1 billion. So that will actually help in optimizing as well as communicating the numbers to the end user when in case if you are trying to show how the project will look like. So this will actually come in handy in case if you want to use that. But in case if you do not want to apply that, just keep that as one. Then we have the regenerate dimension section, which will actually force the regeneration of a particular dimension or all the dimension every time you run the generator. So by default, what happens is that if you run the generator once, then there is a versioning file. You will find that particular section in the data folder. Sorry, I think in the should be I think in the data folder once I actually run the generator first time. So there is a versioning folder which contains the versioning of each dimension. So basically what happens is that when you run the generator, it will always generate the sales file. But the next time you run the generator, if the configuration file has not changed, if you have not changed the number of sales rows or the any row in the dimension or the date columns, the start date and end date, then it will not generate or regenerate the dimensions itself. So the benefit of this is that even if you are generating 10,000 rows, 1 million rows, 1 billion rows, the values in the dimension table will remain the same and same values will be used in the sales table as well. So that will actually help in analyzing how the same customer actually behaves in a larger data set or what is the growth for a particular trend, let's say products or customers or any other thing in the 10,000 version, 1 million version, as well as 1 billion version. But in case if you want to force a regeneration of all the dimension, you can always select any dimension that you want. You will also notice here it says regenerating dimension, customer, exchange rate, and promotion. And in case if you want to regenerate all the dimensions, you can simply check this particular option. So first of all, let's uncheck everything. And this section says that validation chunk size exceeds total rows. The reason being the chunk size is of 1 million, but the number of rows in the sales table that we are generating is 100,000. So let's try to run this, and we have actually selected the Parquet format. And you can see that here it prints the info done. First, since we are running this generator for the first time, it says that generating geography done. Then it generates the customer is done. Then it generates the stores, promotion, products, etc. And since we're generating fake products, the original Contoso database only contains 2,500 products. But since we are generating around 8,000, I think 5,000 products, it says that we are expanding the Contoso products. And as well as you can see that since we change the dates, it is actually updating the exchange rates files as well. So now the generator is complete. So what we can do is go to that folder and you can right now see since we ran the generator for the first time, we now have the versioning files. So based on these versioning files, the generator actually decides whether it needs to regenerate the dimension or not. So let's go into the root folder, and under this folder you will find all the generated datasets that you have actually used generated from the generator itself. So we have generated the Parquet file, and the format of the naming format is basically date time, the amount of rows in the customer table, as well as the amount of rows in the sales table, and then finally the type of format that you have actually used. So in case if you have used CSV, the ending will be actually CSV. So if I open it, you will always find that the tables are actually categorized in under dimensions as well as the facts table. And in case if you want to load the data inside Power BI desktop, what I have also done is in the samples you will find under Power BI we have templates. So in case if you are working, if you want the CSV files, you can use the CSV import template. In case if you have generated the Parquet, you can use the Parquet import. And in case if you have loaded the CSV data inside SQL Server, then you also have the SQL direct query and the import template. And these templates contain the complete folders, all the tables, all the relationships, as well as the proper layout so that you do not have to do a lot of things. So let's go back to the generator and let's try to generate the CSV format by using the same configuration, and you will notice that this time it will not regenerate the dimensions. So if I generate the data, as you can see, here it says skip, skip, skip for all the dimensions, because based off the versioning, it has decided that it has identified that we do not need to regenerate those particular dimensions. So here you can also see that the engine tried to spawn 8 worker processes, but since we are only generating 100,000 rows, it cannot actually do the task with the help of one single core itself. So the pipeline has completed in 7 seconds, but earlier it actually completed in around 15 seconds because the dimensions were regenerated. So if I go back into the dataset folder, so this is the folder. At the root level in the CSV folder, we have the SQL scripts. These two scripts will actually create the dimension and the fact table. These two will import the data inside the dimension tables as well as the fact table. If I go into the dimension folder, we have all the dimensions same that we have seen inside the Parquet, but now we have the CSV folder, and the facts table contains a single CSV file. In case if you are generating more files, the more rows in the sales table, you will see more CSV file here as well. And finally, we can also generate the Delta Parquet format. So if I run it, let's wait for that to complete, and you will see that since we selected this option in the sales table, we will not have the sales order number and the sales line number column. But now I'm going to actually uncheck that so that we can generate those two columns. So if I expand everything, you can see that those columns are not included in the final output. So let's close that. And if I go into the generator, it has actually completed. So we can actually look at the output of that folder as well. So the dimension folder this time doesn't contain CSV or Parquet. It actually contains the Delta Parquet. So we can see that we have the Delta log here as well as the Parquet file here. If I go into the sales table, by default, it will be actually partitioned by the year as well as the month number. So you can see that for every year, we have 12 folders, and inside those month folder, we have a single Parquet file for that particular month. And at the root level, we have the Delta log for that particular sales table. So now what we can do is we can go into the generator. Let's generate the CSV file and uncheck this option. And if I generate the data once again, this time you can see that sales will be always regenerated. And if I go into that folder, let's go back, go in. So we can try to open the CSV file for the sales. And towards the left, you can see that these are the two columns that we actually were removing earlier based on that checkbox. So next what we can do is try to import the CSV files inside the SQL Server, and for that you can go to GitHub and use these scripts either for the Windows authentication or the SQL Server authentication. So let's go into the terminal, and what we need to do is we need to paste this code. I've actually already copied the path to the CSV folder that we have already generated right now, and let me just make sure that the path is correct. And what you can do is here you can specify the name of the server, the name of the database, as well as the type of connection that you want to use. So if I press enter, it will actually start the import wizard, load some scripts, and create the tables inside SQL Server as well as import the data. So let's go into SQL Server by using SQL Server Management Studio. We can refresh that, and you can see it has created the sales 100K database. So we can expand the tables folder. We have these tables. So if I try to preview the data of the sales table, you can see the data has been loaded correctly. We can preview the data of any random dimension as well. So that's how you can actually import the data from CSV into SQL Server by using that particular script. And finally, what we can do is try to generate a large set of data, let's say 100 million rows, and see how much time it will actually take for generating that particular data set. So what we can do is we can use scripts, run UI, and this time we can actually apply the preset for 100 million. So what we can do is generate 5 million customer products, 100,000 looks good. We are going to use the Parquet format, and I'm going to skip the generation of the order number columns because it basically takes a lot of time and space on the disk. So we can actually do that after the completion of the process. So we are going to generate the data for 5 years. 100 million rows is fine. We can actually increase the number of processes that we can provide to the generator. So basically the number of cores, and then the dimension and the stores appear fine. So what we can do is click on generate data. And this is actually going to take around 1 to 2 minutes for generating 100 million rows. And I think that is a good speed considering that we are actually using Python to generate that particular database. So now the generation of the customers, and I think the product dimension is complete. So it has actually started spawning 12 worker processes so that it can use 1 million chunk for each particular Parquet file. It will create multiple files of 1 million chunk, and then later it will consolidate all those, I think 102 files into one single gigantic Parquet file. And you can also see that it is printing one of 102 work. So basically each core is now actually creating a separate Parquet file. And you can see that now the chunks generation has completed. So it is trying to merge all those smaller Parquet file into one large Parquet file. So the generation is now complete, and you can see it took around 1 minute 43 seconds to generate 100 million rows without the sales order columns. This time what we can do is we can uncheck this option, and we are going to keep the same configuration, but we are going to force the regeneration of all the dimensions. So let's generate the data once again. So the generation is now complete, and because of those two columns, it is now taking around 16 seconds more than before. So I think that is a good performance considering that we are generating 100 million rows and 5 million customers. So now what we can do is I can show you how you can actually generate the data without using the UI version itself. So if I go into the project, what I can do is I can open that in the code itself, Visual Studio Code, and you will find this config file that contains different options that you can actually change. For example, you can specify the output folder. You can specify a different seed that will be used for generating the numeric columns as well as the data itself. Then you have the start date and dates, the path of the geography file, because the customer table and the store tables are actually dependent on the geography file. Then you have the Parquet folder where the Parquet files are actually stored, and the out folder for the sales table. You can specify the total rows, chunk size, file format. Then you also have the row group size, which will be effective for the Parquet and the Delta Parquet. Then you have different settings that you can actually find the definition for those in the GitHub project itself. Then you can specify the workers as well as the compression type, either the snappy or ZSTD, etc. Then you have the partitioning columns for the Delta Parquet. Then similarly, there are many settings for the products, the customers table, geography table. For example, in the customers, you can specify how many customers should belong to India or let's say USA or Europe, and how many of all those customers should be the organizations. And then there are many customer name files that are actually located in this particular path. that you can actually change or add more, so that in case if you want different customer names. Then we have the geography location. You can specify how many cities, countries, or continents you want from a particular geography. So right now we are only interested in United States, India, United Kingdom. I'm not providing any values for the rest of them, but you can also use them. Then we have the promotions. You can decide how many seasonal, clearance, or limited promotions that you want to generate in the promotions table. And similarly for the stores table, dates dimension doesn't have anything specific that is not available in that UI version. Then we have the exchange rate, where we are currently only specifying these currencies. You can try to increase that. I think it should work, but I would be actually careful while changing this particular config for the exchange rates. And once you have actually changed the config file, so let's say I actually generate 200,000 rows, what I can do is I can do open a new terminal. And what I need to do is, sorry, to not open the terminal, what I can do is open the main.py file and I can run that here as well. So it will do the same operation that we have seen inside the UI version itself. So the generation is now complete and we can go into the generated data folder, and we have generated around 200,000 files, sorry, 200,000 rows in the sales table. If I go into the facts folder, this is the CSV file that contains the data. And before that, what I can also do, before wrapping up, what I can also show is that in case if you generate a lot of rows, then there will be multiple CSV files. So let's try to generate 20 million, I think, or maybe 2 million rows. So if I run it, this time you will see that there will be many CSV files inside the sales folder. And while that is generated, what we can do is we can look into the template files that I provided with this course, sorry, this project, and we can go into the samples Power BI template. And what we can do is we can try to use the Park import template. And if I go back to the generator, it has completed the data generation. So let's go back into the generated data set. And in the facts folder, you can see that there are many files, 21 CSV files that contain the data, around 1 million rows per each file, because we have specified that inside the config file. So what we can do is go back to a folder that contains the Parquet files. So I can copy this path till this point, go into the Power BI desktop, keep that template open and provide that path. If I click on load, it will start loading the data from those Parquet files. It is taking some time because we have generated around 5 million customers. So let's see how much is the total size of that file. It is around 200 megabytes and the sales table is complete. Okay, so I actually realized I was trying to load the data from a folder that actually had 100 million rows in the sales table. So that was going to take a lot of time. So I've actually switched to a different folder that contains 100,000 rows in the sales table. And in case if you see this kind of error, you can simply close that and refresh once again. It will start working. I'm not sure why it actually throws that kind of error, but after you refresh it or reprocess it, it never throws that error. And what you can do is just click on this slicer to clear the selection. And this is the data that you will see in the visual. Now what we can do is quickly look into the data that is inside those tables. So in the sales table, these are the columns and this is the data. Then you also have the data for other dimensions as well. You can try that and see how you can use that in your own way. So that's how you can actually generate large scale data either in the CSV format, Parquet format, or Delta Parquet that you can use inside Microsoft Fabric by using the Python and this particular project that I generated end to end with the help of ChatGPT. And that was all for this video, and I will see you in the next one.